OpenCLKernels. The kernels are a function. It's a function executed by the work items. And this function, the kernel, can use two interesting variables that give it its ID. It can be a global ID with that function, or it's a local ID inside the work group. Let's look at an example. So, the first thing you can see is that the kernel is given as a string. This string will be sent to the OpenCL compiler. And inside this string, we have a function that has the keyword kernel, and it has a keyword, some keywords in front of the parameters. So global means array is in the device memory. And this one is just a value, so it doesn't need much. Another thing in here to note, so here I'm using the global ID, so the work items are numbered from 0 to the number they are. But the array dimension, the array size, can be a bit different. So I put this guard to ensure there is no out-of-bound accesses. So this is to prevent out-of-bound accesses. So we have seen that last time. So now we will see how to create the executable kernel, set the argument, and execute the kernel. So to create the kernel, I first need to create a program, and this is where I will give the string. This string contains the kernel source code. Okay. Then I build the program. This part compiles and link, and then I have my object I will be able to use to execute the function that has been compiled. Now I have to bind the argument to the kernel argument. So here, argument 0, I will say this will be the buffer I have created before. So this will correspond to the array argument of the kernel. And the second argument, number 1, will be the variable count, called count of the kernel. Now, I just have one thing left to do. I take my kernel and I put it in the enqueue command. There is one data that is still missing. I need to tell him a number of threads. So that will say this is the number of work items. The total number of work items. I'm not specifying the work group. So that would be work groups. So I leave the OpenCL runtime to decide the size. And then, because this is asynchronous, I have to wait for the command, and this is here the role of CL finish. So the question for this part of the course, try different size of work groups for the kernels and see what happens. And also add a syntax error in the kernel source code and compile it and see what happens. So you can use this part, this piece of code, to actually get a report compilation error. Okay, here are the pointers towards the functions in this lesson, and see you in class.